They all just happen to happen in distinct universes.
Right. And weirdly, that's a conservative idea.
Mathematically conservative.
Yeah.
And that's actually a vital point. And this is an idea that's hard to communicate to a general audience. I'm sure many of you are technically trained, but those who aren't, if you stare at the equations of quantum mechanics and just take them at face value, this seems to be where the math takes you. But does that convince you? So are you guys convinced? Brigitte, you...
There are alternative perspectives.
But what about, why don't you like this one?
I like it. I think it's fascinating. I think it's wonderful. But let's bring in some information. So how much information are we going to keep? So this many worlds hypothesis would say that we're keeping every single piece of information.
Yes.
But if we have a measuring device, and then the measuring device is interacting with an environment, and the environment outside is also playing a role. It's also affecting the measuring device. And of these many, many options, measurements that can be recorded by the measuring device, if the environment which is interacting with that measuring device is interacting with the measuring device and produces many more outcomes, and yet then we throw, in producing much more information, but then we throw all of that information of the environment away, then we're left with something which reduces to just one of these options.
So you're talking technical language of what's called decoherence.
Yes, but I'm introducing this technical term that the coherence of the wave function, the preservation of these